So today we will continue our discussions on identity management that we started last week on Thursday, and then we first introduced the concepts and basic ideas about identity management. What is identity? How digital identity is similar and how it is dissimilar with respect to real or physical identities. And then we said that it is important that for digital identities to be maintained in not a centralized repository, which can have its own issues, and there could be certain types of attacks that would be carried out. So we motivated, and then we uh, discussed about the different types of decentralized identification methods, or maintenance of decentralized identifiers. Specifically, we also talked about DIDs, and we saw that how these DIDs can be maintained in some uh, data repositories, and how it has certain standards, specifically the ones set up by W3C. So these are the ones that we talked about, DID, and then we also discussed about its security, and then why we should go for decentralization of DID registry. And from there, we got into the discussion of how blockchains can support that. And as we mentioned, that Hyperledger Indy is one such, which supports this DID registry, and we'll have some tutorial on it. Also, there was this side tree, which provides DID networks that can run atop any existing permissionless blockchains also. And then we started our discussion on binding DID to physical security, and from there we went on to introduce this concept of verifiable credentials in our last class. So if there is any question on this, you may please ask. Otherwise, we will proceed with our discussions on verifiable credentials. Is there any question? Okay, so if there is no question, then let me do a very quick recap of what we said yesterday, because we'll continue our discussion on verifiable credentials today, and then we'll wrap up our discussions on identity management. So today will be the last lecture on identity management, and we'll take up a new topic in our next class. Now, we said that these verifiable credentials, again, this data model is a W3C recommendation, and we looked into that particular site. And once again, as mentioned yesterday, I would encourage you all to take a look at this site. It's very well written, and the basic concepts will be clear beyond what is there in the slides and the recordings. If you go through it once, you will get a very good grasp of what is meant by these VCs, the verifiable credentials. And then we mentioned that these VCs are essentially digital representations of credentials similar to physical such credentials like driver licenses, university degrees, and so on. And the goal is to decouple issuers, holders, and verifiers. And of course, these are made cryptographically secure, privacy respecting, meaning the holder of the VC can selectively present part or whole of the VC to different verifiers based on the requirement and what the holder feels he or she is comfortable sharing with the verifier. And very importantly, that it tries to maintain a standard schema for each such VC. So for driver license, there could be one schema; for university degree, there could be another schema, and so on. And then, based on that, the schema which would be known to the verifier also, that the machine verifiable, this verifiability, this property can be ensured for the VCs. And now, this was the last slide that we had discussed yesterday. I am once again quickly repeating what it depicts. So we have this verifiable data registry where the issuer and the holder, they can maintain their identifiers, and the schemas, most importantly the schemas, as we said, that schemas for different types of such credentials, these are actually maintained in this VDR, the verifiable data registry. The issuer actually would issue the credentials to the holder, and then the holder from time to time can present it to the verifier, who can verify the credential presented by the holder, and also check for the identifiers and schemas from the verifiable data registry. So that takes us to this slide today. So this is the slide which we did not have yesterday, so where we will discuss and describe in a bit more detail about the steps. So the definitions again, once again I would suggest that you can take a look at the site here, as was mentioned, because it gives a very precise definition and also links it to further the glossary of items and so on, and also it discusses several use cases, which will give you a very good idea about how this whole concept of verifiable credentials works. So let us see that who is a holder. Holder would be say people like us, you can consider, who can possess one or more these VCs. And for example, I could have a VC from my university, I could have a VC from the motor vehicles department, I could have a VC from the um, my corporation or municipality about my birth certificate, and I could also have a VC from my employer about my current designation, and maybe it's equivalent of an ID card, and even sometimes one could have a photo also, as we'll see later. Now, example holders are like this, as mentioned here. So these are the holders. Now the issuers, these are of course, as we just now mentioned, so these would be like the universities, governments, employers, and so on, and they assert claims in the physical world about one or more subjects. Of course, there could be so many students, and they create these VCs from these claims. So, if the university asserts that, say, this person A was a student of the university in this department from, say, 2018 to 2022, so that is the asserting the claim about a particular subject, say A or B, and so on. And then based on that, VC can be created, and this VC, mind it, is transmitted to the holder. Remember, this verifiable data registry is not going to store these VCs. So this point you should not misunderstand, because the VCs are not stored in a central location or even in a distributed or decentralized location, because that will be too many to store, and that is not the whole goal. So essentially, as you can see, that it is almost equivalent to the happenings in the physical world, where a university does not store all the identity cards of all students in any central location, right? So they issue that to the holder, which is these individual students, and they can now use it for different purposes. Okay, so similarly, this issuer is issuing this VC to the holder, but this verifiable data registry is not going to store any one of those VCs. The subject is the entity about which claims are made. So example subjects, of course, include human beings, animals, and so on. So holder of a VC might not be the subject. So a good example is that a parent, I'm sorry, a parent might hold the VC of a child, okay, or a pet owner, the holder might hold the verifiable credentials of their pet. So there is this distinction between the subject and the holder, but of course, the holder itself can also be the subject. And then it should be noted that some credentials might even be self-certified by the subject. So I could certify certain things myself as a subject, and I could also be then the holder. So, for example, I could say that I know person B. So that is like a certificate that I am generating myself. So the usefulness of that could be that if someone wants to check whether indeed I know B, then or B knows me. So that particular VC could be used. If you see certain examples that we write in our resume, often that the list of references, people who know me, right? So that is our self certification, that if you contact this person, then this person can write a letter of recommendation for me. So we are making a claim that I know this Professor X, and Professor X can write an LOR for me. So if a university contacts Professor X, then of course Professor X typically would not deny that he knows me. But that is something similar to what is about self-certification by a subject. Now the verifier, so the verifier receives verifiable presentation to assert claims about subject. For example, if a student holds this VC, which is the degree certificate and the transcript, and at some point of time the student applies for a job, in that case, now this holder is presenting this VC or part of it, depending on what is required by the employer, and this employer is now acting as the verifier. So as you see that example verifiers include employers, security personnel, websites. Just as you can present your ID card to the security person while entering a building, so similarly you can also present your VC for entering a building. And the verifiable registry, we have already discussed that most importantly, it keeps the verification of creation and verification of the DIDs, and it also keeps VCs, these VC schemas. Uh, Other important aspect is you might not be able to see it. It's a little to the left bottom. Is that revocation registry? So what can happen is that say there is this motor vehicles department that issues a driving license to me, and then I can keep presenting. But suppose that the motor vehicles department has revoked my license, okay, but my license does not, physical license does not say it has been revoked. So it is presented somewhere as an ID, and then people will believe it. Okay. So now, in case of this digital identity, of course, it can be done because of this verification when it's being done by the verifier from based on the presentation made by the holder. Then the verifier also can check from the verifiable data registry whether that particular VC has been revoked by the issuer. So that is an advantage of using such types of digital identities. Now, if we see that this VC data, what it contains, so these are claims like, say, Pat is alumni of Example University. So this is what we just now mentioned. Example University is issuing the VC to the holder Pat. Okay, and this itself can be a little bit more complex, or even it can have different types of such connections. So Pat knows Sam, and Sam has a job title of professor. No, so in this case, maybe the Sam is a job title of professor is given by the employer of Sam, which could be again some other universities, example two university, and Pat can self-certify that I know Sam. So that is what I was talking about. So the overall the verifiable credential has these claims and then certain proofs, and also there is a lot of credential metadata. So this metadata itself could have information, extra information like some representative uh, figure, and it could even be a photo if required, but that of course is not mandatory. But it could be like representation that it is a student ID type of VC, so there could be something like scholar's image and so on. So there could be something to depict what this VC is all about. So there could be a lot of such credential metadata, and you can also, if you wish, you can see here about all the different types of credential metadata that are possible. So you could take a look at this, okay, that what is there. So some more details about the issuer and all. And of course, we could also have an expiry date and time and so on. This representative image is what I talked about. So you can see some more details from the site. Now, next we move on to what is called the information graph of a basic verifiable credential. So look at this example that here what we have is that we have here the verifiable credential. Now, if you look at this, that this is having this information about the issuer is some example university, and then for this VC, the subject is Pat, as you see, and then what is being very certified here is that Pat is an alumni of example university. So that is the basic credential that is being issued by the issuer here, which is example university. And then what type of VC it is? It is the alumni credential type of VC. Okay, so this is the type. And then there is an issuance date, that on this date this was issued. Now, and then there is some credential 123, so that is basically the credential of the issuer. So that would be uh, uh, basically making use of the private key of the example university, and the public key will be known to others. Now suppose this particular VC is being issued to any say holder. Okay, so now of course that the supporting information would be that there is a signature. So how do I prove that this indeed is a valid VC? Okay, so then what it would mean is that this signature 456. Okay, so that is basically the example university's public key. So it would be the public key of the university, and then it will say that what type of public key you are using. Say it is RSS signature, and then the value of the signature. So after it has been digitally signed, the VC has been digitally signed by the issuer. So then this is the signature value, and using this public key, we should be able to decrypt this signature and then check indeed it was issued by the particular university, which is say this example university. And then we could also have this created. So that means one part here, the issuance date could be that when that PAT became alumni of example university. Say on 1st May 2022, PAT became alumni of example university. So that is when this became uh, active. And then this particular proof was maybe created on a different date. So we could have a different date from what was the issuance date. So these together form a proof for the VC. So as mentioned here, that for PAT, this credential graph, along with the proof graph, they make this verifiable credential for PAT. Now, that is what, if you see that, that is what PAT is holding. So if you see here, this holder got this from the issuer. And then holder PAT is not making use of it for 5 years. And then at some point of time wants to prove that he indeed went to example university. So now PAT is presenting this VC, part of it possibly, or whole of it, to verifier, okay, who wants to check that indeed Pat had gone to that particular university. So verifiable presentation is what is now being sent by Pat to the, say maybe to an employer, for example. Okay. So as you can see on the left, so verifiable presentation, that includes the verifiable credential, the presentation metadata, some more information about it, and the proof. So which is what we'll come to. So a verifiable presentation expresses data from one or more VCs. So even data from multiple VCs could be combined into one such presentation made by, say, PAT. So one could show that this is part of it is that I went to example university and I went to say example to school and so on. So all those things he could combine and then present. And it is to be packaged in such a way that the authorship of the data is verifiable. So holder has to convince that indeed the VC was issued to him. So this part is important. Now that PAT is presenting it to someone, say some say employer, for example, where PAT claims that he went to example university. So it should be presented in such a way that this employer would be convinced that indeed now this particular VC was issued to PAT. So it is not that PAT is making use of somebody else's VCA who was there in the example university, and now PAT is claiming that he also was there in example university. So what we see here is that if you see that outer dotted rectangle on the top is a presentation graph. Okay, so here if you see that it was the credential graph, and then there was a proof for the proof graph for the credential graph. And so we could call that as credential proof graph. Okay, and here what we have is that we have this as the presentation graph, which contains the verifiable credential, which is what was received from the issuer by the holder. And then we have this additional information that which is showing that how to uh, ensure that at the time of presentation that indeed what extra information that Pat is providing. So Pat is saying that it is a verifiable presentation, and then it is a presentation, say ABC, and uh, then which refers to this particular credential graph, and then there could be terms of use that I am presenting it, but now you cannot archive, and then you have to discard. So assuming that the machine verifiable these protocols, they are going to honor these, like about say when you crawl some websites, so for robo exclusion protocol, so they are not supposed to be crawled, those websites, so these are to be honored. So similarly these need to be honored by the verifier. What is important here is that the bottom part, which is the presentation proof graph. Okay, so what it says is now when Pat is presenting it to an employer, Pat also has to prove that this particular VC was indeed issued to him. So then Pat will have to digitally sign it, and then it should be able to be uh, retrieved or decrypted by Pat's public key. Okay, so that is what this bottom part is showing. And then here also you see that it says that when this particular presentation graph was created, so that means when Pat is now presenting it to the employer. So Pat might have got the credential VC from the example university 5 years back, and now Pat is presenting to an employer. So now this particular presentation that is being made, so when that was created, and then of course the signature value and then public key of Pat is here, so that it can be actually decrypted and be checked that indeed Pat is presenting it. So it should not be a case that previously Alice has presented and now Pat is actually sending it to the employer. uh, so now the employer, what employer should be convinced of is that one is that indeed that this particular VC was issued to Pat. So that is what the employer should be convinced, and also employer should be convinced that indeed that Example University had issued it to Pat. So it was genuinely issued by Example University. Okay, no, it is not that something Pat had concocted and now presenting. So if we look at this verifiable credentials flow, so life of a single verifiable credential. So the issuer, so issuer issues it typically once it issues to the holder, right? That this is your VC. So like to Pat, this example university is issuing the VC, and then Pat can actually transfer it to other places and then present it any number of times, or may not transfer it also, and to present it to verifiers. Okay, and then the verifiers, they can verify from the registry. So if you see the first this what the verifier will have to do when the verifier gets this presentation graph and the presentation proof, so verifier will first check with this that using Pat's public key, they should be able to get back the credential graph because that is something that was actually signed by Pat's private key. So once that credential VC is presented, is available to the verifier. So VC is available, and the verifier has verified that indeed it has been presented by a genuine person, Pat. So now the verifier can check whether this was really issued by Example University. And how will the verifier do? Of course, the verifier now will be using this particular proof, where the verifier will use the public key of Example University and then be able to check that this credential is matching that Example University said that indeed Pat was an alumni of the Example University. And all these Example University and then alumni of all these should be there in the form of the schema in the registry, so that this verification by the verifier can be done by the machine itself. And then what is important is that the issuer can also revoke it. So if something went wrong, as we said, that maybe the driving license was revoked, or maybe this something happened and then maybe even that Pat being the alumni, that was revoked. So what is important is that as we'll see here that sorry that the verifier once verifies that this was indeed issued to PAT and everything is fine. But then finally, the verifier also will have to verify that this particular VC has not been revoked by example university. So as I said, that my driving license could be revoked for certain actions, and then if it is only checked if it was issued to me, then that is not enough. So the issuer, the motor vehicles department, might have revoked that. So that also is to be checked from the data registry. So that is how this whole cycle works, and then it can be deleted and so on and so forth. And this pad could save it anywhere, and then it could be presented. So every time it is presented, it has to be ensured that it was indeed issued by the issuer to pad. So what is the trust model? So you see that so far we are saying that someone is doing this, someone is doing that. So who is verifying their authority? So it is important that here the trust model is such that this issuer, holder, verifier, so acting in any one of these capacities does not require any registration or approval by any authority. So it is all the trust that is bilateral between the parties. So if it is PAT who is presenting this information to the verifier, say the employer, then it is the employer who trusts that that PAT indeed is a right person. Now, what is meant by PAT indeed is the right person? So far, we just now talked that there could be someone else presenting and so on. So you see that we mentioned that the verifier would check that this particular credential was indeed issued to PAT and PAT is presenting by checking it against the public key of PAT, which is there in the data registry. Now, who kept it there? So it must have been kept by somebody, and that is what we discussed in the context of DIT. Okay, so then Pat must have kept his public key there, or any other controller, as we discussed before, would have kept that information about Pat. So it is all about this trust that if it was self-certified by Pat, and then if that itself is sufficient for the employer, then it is going to go by the public key of PAT, which is there in the repository itself. And that is what we are showing here, just for linking it back to this diagram, that you see that this verifiable data registry maintains the identifiers and schemas. So these are basically these identifiers referred to the public keys. And similarly, that once the employer is convinced that it was indeed issued to PAT, now whether it was really issued by a genuine example university or not, again it is about the trust between this verifier and the university, where of course the DID of the issuer, the example university, will also be there in the this registry. Okay, so this will also contain the verifiable data registry, also will contain the identifier of the issuer. Now, so far these identifiers, what we said is that it is just any identifier. It need not be DIDs. We'll come to that very soon. Now, so that verifier trusts the issuer to issue the VC that it received. To establish this trust, of course, a VC is expected to either include a proof establishing that the issuer generated the credential, or VC has been transmitted in a way clearly establishing that the issuer generated VC is not tampered in transit or storage. And of course, these are all done by means of the digital signatures that we discussed. And the other point that is important, the third point is very important. So the entities, of course, trust the verifiable data registry to be tamper evident and to be correct. That is, it is not playing with these identifiers for the issuer or the holder. And of course, that is what is the point of. So this VC as such that we are discussing is independent of Yeah, can you hear me now, Sandip?
Yes, now you are audible.
Oh, okay, okay. So it dropped off in between. So I'll continue. No problem.
Yes, sure.
Yeah, yeah. So what I was saying is that so it is this VDR is supposed to be temper evident and be correct. So of course that is where blockchain can play a big role, and that is what we'll also mention towards the end of the lecture. And the holder and verifier trust the issuer to issue true credentials. So of course that it is expected that the example university would not issue this credential saying Pat was an alumni if he was indeed not. And if there is something wrong, then it can also be revoked, and the same would be updated in the VDR, so that while verifying, the verifier can also check against these the ones that have been revoked. So if we see now combining DIDs and VCs, so far as we said, the identifiers need not have been DIDs actually in the VDR. So if we combine DIDs and VCs, so of course the first step would be to create these DIDs, right? Both for the issuer and also for the holder. Okay. So you see that Alice is creating an entry, her DID document, and so DID registry one Alice, and similarly for the university. And in this case, if you remember what we said, that let us assume that Alice herself is a controller also, so she can create and register her own DID document. And then Alice would request transcript VC to be issued to DID registry one Alice. Okay, and then the university would fetch DID document, DID registry Alice, and check that indeed this is the public key of Alice, and then it will send it to the transcript VC would be sending to Alice, and Alice also authenticates as controller of the ID registry, one Alice. So that Alice herself is the controller. And then once the university is issuing the transcript VC, so effectively what we know is that the holder is this DID and the issuer is this DID. So that is what is important. So it is being issued by one particular DID DID uh, subject to another DID subject. Effectively, that is what is being done when this VC is being issued by this university to Alice. Now, you can see here that there is some notion of trust, that Alice is saying that you please issue the transcript VC in the name of Alice to this particular DID. So, in some sense, university is now able to it is trusting that Alice, whatever she is claiming to be her DID, is indeed Alice. So, unless, I mean, there could be so many people who might otherwise say that, oh, I am Alice and you send it to me. So, that level of trust is what is used here, that Alice would not say that, oh, you issue it to this DID, which is not her own. Or there could be then controller, but as soon as you bring in more controllers, we are going to centralize everything, and that is what is not the goal. And once in this step Alice has got her VC from the university, so Alice can now prepare the verifiable presentation and do the verification. So say the industry requests the transcript verifiable presentation, so Alice would present the transcript VP with signature authenticating this one. So Alice will signing it with her private key, and the industry can validate the transcript issued to DID registry Alice. So by checking it with her public key, which is available with the VDR, and also that the fact that it was indeed issued by that particular university, that also can be checked by getting the public key of this university, which was done in the first step here, and also using the, remember the presentation graph as is shown here. So using that, the employer can actually verify that indeed it was issued by the university. So in industry can validate issuer of transcript by validating issuer's signature, and then finally it will also check whether there is any revocation of that VC. Then that would also be there in the VDR, and then against that it would be checking. So this is how we can have both DID and VCs working together. Again, I would like to clarify that even if we did not use this DID concept, we simply use some basic notion of identifiers, then also the discussions on VC would hold. But it would make more sense when we actually have DID and VC working together. Then we have true decentralization, and many of these can indeed be supported, or it could be enabled by the use of blockchains. So this is the final slide that this Hyperledger Aries, as we mentioned yesterday also, this is meant for creating, transmitting, and storing verifiable credentials. So we are planning to also have, just as we'll have some tutorial on Hyperledger Indy, we'll also plan to have a quick tutorial on Hyperledger Aries also later this month, so that you will get an idea about how these verifiable credentials can be supported. Specifically, as we said, that the data registry, of course, the property that we said here, that we would expect that the verifiable, the second last bullet here, the verifiable data registry should be tamper evident and be correct, and that is where this Hyperledger Aries can be of help. So we will take a look at that somewhere later this a month. So that brings us to the end of this lecture on identity management, and where in summary we have highlighted the need for digital identities, decentralized identifiers, and we have also talked about these VCs. And in the process, we have mentioned that which Hyperledger project can actually enable which of these different concepts like DIDs and VCs. So, if there is any question, then you may please ask, because I do not plan to take up the next topic, which will be on interoperability today, and we will take it up after the DP holidays. So, if there is any question on today's topics, feel free to ask, and I would be happy to answer, or any other questions, because tomorrow we will have our second test starting at 9. If there is any question on any topic or any doubts about the test, you may please ask. I am stopping the recording now.